Hi, good morning. Hopefully you are fine. I'm Eduardo Jose Sanchez. I'm the coordinator of the Let's Flag platform. It is a pleasure to be with you. I would like to begin this webinar expressing appreciation to C2G for the support to CEPAL Euroclimate. And in this webinar, as you well know, this is an introductory webinar. Insofar, introduction to solar radiation modification, analysis of potential benefits and risks in the context of Latin America and the Caribbean. We thank you for your attendance. Next, please. Next. Alejandra, next slide, please.
Mientras tanto, hay algunos temas.
In the meantime, there are some technical issues, and it's important that we bear in mind. You will see an icon of questions and answers, Q&A, on the lower part of your screens on the right side. Please, any question you may have, please write it in Q&A. The chat is not for questions. It's for special needs or suggestions parallel to the process. It's important that you know we have simultaneous interpretation. We have in English and Spanish. There's a channel on the lower part of your screens, English and Spanish. And you can choose whatever you feel more comfortable with. And also this is being recorded and the video and presentations, and they will be found in the Let's Flag platform. Let'sflag.org. We have a very interesting panel meeting today to discuss this topic. We have three most valuable speakers working on this. We will begin presentations with Paulo Artacho. He is one of the most influential people in the topic in the international arena. He has written several reports, number 4, 5, and 6. He is member of several scientific networks, has been rewarded by the Stockholm University, Dr. Honoris Causa, by the Sao Paulo University, and member of the Science Academy. Inés, she is the main doctor on the impacts of 2.5 and 6 on global warming. It's an interesting topic. And also, she's a professor in the Department of Atmospheric and Ocean Sciences of University of Buenos Aires, main researcher of the Atmospheric and Ocean Research Center, and has participated and led and coordinated several projects, nationally, internationally well known on climate change. Finally, Juan Moreno Cruz is Associate Professor of the Environment, Enterprise and Development School of the Research Chair in Canada on Energy Transitions of the Waterloo University, also an affiliate researcher in CES-SIFO, and so associate researcher from the program of solar engineering of Harvard University. Hopefully you will make the most of their conversation. Everything is open, and this will be, and then we will have a Q&A session, and we will have that once presentations are over. Without further ado, I would like to recognize Paulo. Welcome, Paulo. Hi, thank you very much. First and foremost, I apologize for my very poor Spanish. I will try to go slowly, and there is a combination of more Spanish than Portuguese. However, I hope you will understand me. Well, the idea is to discuss. I will make an introduction, but it is to discuss the aspects of the three global crises that mankind is going through today. The first and one, evidently, is COVID-19. It's the health crisis. The second one is the loss of biodiversity in our planet. And the third one is the crisis on the climate emergency that we are facing in our planet. These three crises have similar points. And there are very important differences among the three of them. Hopefully, we will approach them very briefly. And mainly, we can also refer to how is it that technology of climate intervention, as we say in IPCC, or climate geoengineering, can help us in these crises of today. Firstly, it's important to see that the three crises are evidenced, or first, they evidence an over-exploration of nature. Second, a very short-term view of the economic and political systems by most of governments in most of countries. And thirdly, and what's even more important, is the lack of global governance. What is it that we mean with this? That is the development of our discussion. So these three crises also have one very common important aspect, and that is the decision making based on science-based decision making. It's key. It's key that they be based on science and not based on religious or political beliefs. This is in the COVID crisis. Yes, we have a COVID-19 crisis, but also climate crisis is very important. And this is going to be very clear, science-based. Biodiversity, climate crisis have devastating economic effects, as we are witnessing now. The climate crisis, we already have, or the temperature of the planet has already grown in 1 degree centigrade. And for the agreement is 1.5. And now this 0.5 doesn't mean very much for Latin America. So the planet has already heated 1.5 degrees, but the Brazilian northeast is 2.5, and rainfall has gone down in 30% in Brazil. And in many countries of Central America, they are also suffering in a very strong manner this climate emergency. And this is caused by the emission of almost 40 billion tons of CO2 coming mainly from fossil fuels burning, and also the felling of Amazonia and in Latin America, which these are very important areas for us, the Amazonia. So the climate models, what is it that they foresee is that many areas of the planet will become uninhabitable with temperatures of over 50 degrees. And this will bring about socioeconomic impacts and very serious problems like population migrations that will be impossible for them to survive in certain regions. In particularly, Central America will suffer migration impact. And Also, the northeastern part of Brazil will have very important impacts. The population will need to migrate to other regions. So, along these lines, to avoid these effects, another ones which are of significant importance, for example, the loss of the ability to produce food for 10 billion people in 2050. This loss is extremely important because hunger, starvation can become a central issue, bringing about armed conflicts, trafficking, political conflicts. A second important aspect of climate changes is the extreme climate events with droughts and floods that have enormous impact in our society and also in our economy. For this is that there is a possibility that we may have climate intervention, that is forced intervention in the global climate system. So, we have as a possibility for solution of this climate emergency, the first one is to reduce emissions of greenhouse gases as fast as possible and the largest amount possible. The IPCC recommends that to have at least a reduction of 5% of emissions every single year from 2020 to 2050 so that we can have a good possibility of attaining the maximum temperature increase of 2 degrees. It's already quite a bit because it's 2.5 degrees already in the Brazilian Northeast and Central America, and that could mean 3 to 3.5 increase, and that's a lot. The second possibility is to invest in research related to solar radiation modification to combat global warming with strategies that is allowing a flow of extra heat out of the planet and invest in the technology that is carbon capture and storage. Plant trees because photosynthesis is the best way to absorb that. To plant trees and remove this heat from the atmosphere. Now, this technology has serious problems because it is mainly based on areas. A tropical country will have that effect, and this runs counter to the production of food in the temperate and tropical areas. And then finally, for these three aspects, that is emission reductions, research in solar radiation management and in carbon capture and storage, we have three ways to stabilize and establish a system of global governance in order to manage this process in the coming decades and hopefully throughout the coming centuries. So these are scientifically enormous challenges we have for mankind. However, it's important to perceive that science is not ready to implement technologies with some degree of reliability in solar radiation management or even in carbon capture and storage. For example, recent papers or main journals show that in order to store half of the carbon emitted to the atmosphere, we would have to plant forest in an area of 14 million square kilometers. Imagine, it is a gigantic area, and that would require financial resources, technological, and forest engineering that we don't have. Therefore, this would be very difficult to implement.
A second possibility is the implementation of solar radiation management. Basically, there are several techniques to do this. There are several proposals. One of them is to inject aerosols in large amounts to the stratosphere. Those aerosols could reduce solar radiation flows around 2 watts per square meter in the surface and thus cool down the planet. There's other technologies for solar radiation management, such as altering the albedo of the Earth's surface, such as putting huge mirrors in orbit between the Sun and the Earth to reduce the radiation flow to our planet. These technologies are scientifically yet in their childhood, and they will require much scientific effort in order to implement these technologies. And particularly, these scientific efforts need to come from developing countries such as the Latin American and Caribbean countries. It is very dangerous to leave all the science and all the governance of such a complex process and with such major efforts only in the hands of the rich countries such as the United States, Europe, Japan, Russia, and now more recently China, without the developing countries from Africa, Latin America in particular, to have a strong engagement, that they be strongly involved in this process. So those are extremely important and delicate aspects which are crucial for mankind. In order to end, it is important to perceive that for climate issues relating to COVID-19, there is no possible lockdown. The best strategy against COVID-19 is social distancing and lockdown. But to deal with the climate crisis, that is not possible because we cannot block the whole problem and stop all socioeconomic activities. COVID-19 has shown us extremely important aspects about governance. You can see that European countries decided on an individual basis, country per country, decided what was the best strategy to fight COVID-19. Strategies from Italy, Germany, Spain, UK were all different. For a health crisis is global, it would be much more effective if we were able to structure global strategies. Well, the same thing happens here in Latin America. Argentina and Brazil had completely different strategies, and Brazil unfortunately chose the worst possible strategy. And today we have more than 1,200 deaths per day continuously through the last 2.5 months. So the issue of global governance and regional governance is absolutely important. But apart from that, it is important that there be a single solution for these issues, which is to change our economic development and social development model. Our current model is based on the increase of social inequalities and the concentration of income for those who already have income, and to have the more vulnerable sectors of our population become even poorer. And that is not sustainable in the short or medium term. So it is very important for us to work trying to change the development model towards a development model including more social justice. And to that end, the best recipe for the countries of Latin America and the Caribbean is basically to implement the Sustainable Development Goals from the United Nations. To ensure that all the countries of Latin America and the Caribbean be implementing, even Brazil is implementing it. This is the only way to build a society which is minimally sustainable in the environmental area, in biodiversity and health. Climate intervention can be an instrument, but it is important to see that science and the government for implementation are not yet ready in the developing countries. They need to contribute to development and structure a system of global governance that can take our planet to a more sustainable trajectory. Thank you so much, and I apologize for my Portuguese. That was more Portuguese than Spanish. Thank you very much, Pablo. Thank you, Pablo. It is truly a pleasure to have you. We welcome Inés. Welcome. Thank you. Thank you very much. I will be sharing my screen. I will be talking about the experience on the study of the solar radiation management in Latin America and the Caribbean. So, in order to put this into context, let's talk first about the problem represented by climate change and why we are talking today about the solar radiation management. And this deals with what was agreed within the framework of the United Nations Convention on Climate Change and the Paris Agreement on the great need to stabilize the increase of average temperature of the Earth in 1.5 degrees. By virtue of the impacts that would be associated in overcoming this warming would have impact upon health and food production, on the occurrence of extreme intense events more frequently, many of the issues that were just referred to by Pablo in his presentation. So the image that you see in your screen somehow would represent the ideal pathway that the temperature of the Earth should follow. We know that we are going through a process of temperature rise. And the best thing that would somehow happen is that said increases be stabilized, as that the image shows, stabilized at 1.5 degrees without going higher than that. But the trajectory, the pathway that we've been followed, since the greenhouse effect is increasing, it tells us that most likely what you see in the screen is what might happen. And it is that for a given period of time, we may go beyond this 1.5 objective. And then that we may manage through some strategy or mechanism that we may manage to cool down the planet. Of course, the consequences of this period of overheating or overshoot, as we call it in English, of going beyond 1.5 degrees in the increase of global temperature as compared to the pre-industrial level, may have very different consequences in terms of how long this overshoot will last and how much we surpass our objective 1.5 degree. And this is absolutely central because we overshoot for too long time or in temperature values going beyond the 2 or 3 degrees, the loss of biodiversity can lead to the disappearance of certain species that can no longer be recovered, that the loss of Arctic ice and Antarctic ice be massive and that cannot be recovered, even though subsequently we managed to attain the stabilization at 1.5 degrees. So The main objective should be not to surpass global heating in greater than 1.5. So the mitigation policies of climate change, the reduction of emissions, seems to be something that's fundamental, but also represents a major challenge. We're saying that in order not to surpass 1.5 degrees heating from here to 2030, we should reduce our emissions in the order of 45%. And the greenhouse gases emissions and attain the objective of being carbon neutral, which means compensating what we are emitting with the processes of a carbon dioxide capture, and we should attain this by 2050. So the mitigation objectives are present. We must try to attain them, but we know that the pathway in which we are currently would seem possible that we may surpass, we may have an overshoot from the 1.5 degrees. So our central role is how could we, if we go beyond the 1.5 degrees, how can we manage to lower the temperature? How can we cool down the planet somehow? And this is where the geoengineering strategies appear as a technological alternative, as an option to lower the average temperature of the Earth to thus finally be able to stabilize it at 1.5 degrees. So these strategies that we call climate engineering involve precisely the modification of solar radiation. What I'm going to show you just with an example of applying a strategy for solar radiation modification, which is a deliberate strategy of continuing to act upon the climate. In this case, this manipulation deals with searching for alternatives to counteract the negative effects of the increase of greenhouse gas concentrations in the atmosphere. So then the question is, what consequences could there be to the implementation of this type of technology, this type of strategy? And so in Argentina, in this sense, we made a proposal to assess the possible impacts of the implementation of solar radiation modification in the hydrologic system, the hydrology of the Plata Basin in the southern part of South America. We are a set of researchers from the University of Buenos Aires, and we count with a cooperation of researchers from abroad. This project is funded through a fund which is known as Decimals. This fund aims to contribute with scientific research in developing countries so that they be local researchers with the support from foreign researchers in the evaluation of possible impacts that interventions in solar radiation may have at a regional level. We chose to work in the Plata Basin, which is what you now see in the screen. It's a region of the southeast of South America, which is shared by 5 countries of the region: Brazil, Paraguay, Argentina, Uruguay, and Bolivia. It is a region which is highly relevant in terms of water availability. It has 3 large rivers: Paraná, Uruguay, and Paraguay rivers. You can see these are rivers with a large flow, and they support the generation of hydroelectricity. We have more than 30 large hydro plants that provide energy in different proportion for the countries of the basin. But this is a very relevant activity. And it is one of the regions in the southern part of South America that are the most important in terms of the concentration of population. More than 150 million inhabitants live in this region.
And also providing homes to many of the productive activities of these 5 countries it's highly rich in terms of biodiversity. So any modification on climate and water availability in this area is expected that it will have a tremendous impact on the social and economic activities of countries sharing this basin, river basin. Now, what's the context? What happened with the precipitations, or what are the trends or rainfall? These are the rainfall trends, and there has been a change in precipitations. And what you see in green regions is the area where rainfall was increasing, and the brown ones is where there was a reduction of precipitations. Clearly, in La Plata Basin, which is a square in green, it's one of the regions in the world where the increase of rainfall has been most significant. That increase in precipitations from 60s to date. And this accounts for more than 30% increase in that period of time. This increase in precipitation is translated into an increase in the flows of the rivers I mentioned before. So the research we are conducting has an objective that through climate simulation to evaluate the impact in hydrology of that base, to implement strategies of solar radiation management that will simulate through this physical mathematical tool what are the consequences of incorporating aerosols into the atmosphere so as to reduce the energy reaching the sun and replicating what happens with a volcano eruption. For this, we have worked with the simulations provided by a project that is called GLENS, developed in the US by the National Center for Atmospheric Research. And this GLENS project, what is it that we do with these simulations? Is to compare changes that would exist between a historical period, the observed period, and then how the future would be if we did not apply geoengineering strategies and we continue to emit greenhouse gases with a high degree of emissions, and it would be similar to the trajectory where we are now presently emitting greenhouse gases. And compare that, how the climate conditions would be if we apply this geoengineering strategy with MRS. Or SRM rather, solar radiation management. So these simulations, what they seek is alternatives to cool down the planet. And so for planet cooling. And so what you see on the graph above the black line is what the increase of the temperature would be if we continue to have these greenhouse gases emissions. And the stabilization of temperature in the blue line as a result of managing solar radiation, incorporating aerosols to the atmosphere. In the map, you have the 4 points where these simulations incorporate aerosols, inject aerosols to the atmosphere. These are for 30 degrees south latitude, 15 degrees north latitude, and 30 degrees north latitude. For you to have an idea, these aerosols are always injected in the atmosphere, incorporating in the stratosphere at a height of at an altitude of 20 kilometers. And the volume of aerosols that would have to be injected every single year in order to stabilize temperature according to this blue line that you see on the upper graph. This is to counteract the increase we would have if CO2 continues to be incorporated is represented on the lower graph. The black line shows precisely the total volume of sulfur dioxide that should be incorporated in order to simulate the effect. For comparison purposes, when we had the volcano eruption of Inatubo volcano, a section would be to the Inatubo volcano eruption, and we would be incorporating aerosols that exceed the one Inatubo volcano, and then 3 volcanoes. That is the volume of aerosols that we should inject in order to counteract the warming and trajectory or path followed now in terms of fossil fuel burning and volcano eruptions. So what do you see on the screen? This is the temperature rise, minimum and maximum in South America if we don't apply geoengineering. Or if we do apply the geoengineering, the solar radiation management techniques. And if we can clearly see the difference. What you see in blue in La Plata Basin, that is, we would have precisely that cooling effect that we are seeking, that would be 2 degrees. We will see the response of rainfall in the Plata Basin is not homogeneous. We are speaking about 3 million square kilometers. There are places where rainfall would tend to decrease. If we compared applying geoengineering without applying geoengineering, we would have regions with more precipitations and others with less. And what we would like to evaluate is what would happen in hydrological terms in La Plata Basin in response to these changes in temperature and in precipitation, is that we would need to use a hydrological model that would allow us to evaluate the changes in the flows. And here we use a hydrological model developed by Washington University that's called variable infiltration capacity. And what we see now are the changes that can be expected in the Paraná River and Itaipu. It is where we have one of the most important reservoirs or dams for the production of hydropower, hydroelectricity. There, the star on the map. What the simulation shows is if we don't apply engineering techniques and continue to have high CO2 emissions, the impact on the Paraná or the reduction would be a slight trend to reduction of the average flow. Now, with this solar radiation management injecting aerosols to the stratosphere, it shows us that there would be an increase of 10 to 20% in the flow of the Paraná-Itaipu River. And this can be interpreted as a positive response. Larger river flow could be translated into being used for increasing hydroelectricity in this dam, as there is much more water available. But when we see what could happen with minimum and maximum flows, river flows in Itaipu, what we can see if we didn't apply these geoengineering techniques in a high emission scenario, the clear red color, we would have ever more minimal river flows. So it's important to bear in mind that for some months now, at the La Plata Basin in Paraná, river power, but also navigation possibilities, which is important for transportation of the production of that basin. With the implementation minor minimum river flows, at least in Paraná and Itaipu basins. And if we think about maximum river flows, what we have with geoengineering flows would tend to increase, would be, or the increase would be more significant with geoengineering. So we would have extremely high river flows, and thus that could lead to floods that would be severe and important, and therefore the response there would be almost negative with these technologies. So what is being studied and analyzed based on all of these results is that climate change produces asymmetries, enormous asymmetries, not only as to differences insofar as emissions, but also on impacts, and to apply strategies like the radiation metric responses. Therefore, the implications of the use of geoengineering from the statistical standpoint is also very relevant because they show variability in time and space. And therefore, discussions about governance of these technologies play a key role. But it's also important to move forward in knowledge so that emerging countries, developing countries, we may be able to see what are the possible consequences about not only the impacts of climate change, but the impacts of these possible technological solutions that are in the close horizon. That was my presentation. Thank you very much.
Yes, muchísimas gracias. De verdad muy interesante.
Thank you, very interesting. And sometimes I would like to tell the participants that the questions, please write them in the Q&A and try to be brief to the point so that we can answer them all. Now I welcome Juan. Juan, it's a pleasure to be with you. Thank you for the invitation.
I'm going to be giving all the talk in English. I'm a proud Colombian, but I'm used to give in academic talks in English, so I'm going to stick to that. But questions and everything, please do them in Spanish. So let me share my slides, and I think you can switch to English in your channels if you to Spanish. So I'm going to give you 2 seconds to do that while I look for my slides. Are we good?
Yes.
Okay. Can you see my cursor too when I move it?
Yes.
Okay, thank you. Okay, so thank you again for having me. I've been tasked to talk about the governance of solar geoengineering. I've been working on this since my PhD thesis back in 2009 when I finished. So most of this is going to be a summary and an introductory a presentation on the issues that we have been facing when we discussed the introduction of solar geoengineering. I will be talking about the possibility of solar geoengineering implementation, although we are way far from that. That's where most of the research has been focused. So this is not about the development of technologies. It's imagine that the technology exists, imagine that the technology can be implemented, and what happens if that's the situation. So Relative to traditional mitigation, solar geoengineering has very different characteristics. So traditional mitigation technologies and technologies that are meant to reduce emissions of greenhouse gases tend to be expensive in relative terms. Solar geoengineering is not. Solar geoengineering is inexpensive to the point that a particular single country can implement it if necessary, or if they choose to, which is one of the problems that we're going to discuss. Again, unlike mitigation, solar geoengineering, the impacts of solar geoengineering are immediate. That means that when we implement solar geoengineering today, we will see the effects in a couple of years or within a year. And solar geoengineering is also imperfect. It's imperfect in many ways. And again, this is relative to mitigation. So when we do mitigation, what we see is a reduction in the same cost, in the same emissions that are causing the problems. So pretty much we're backing up the climate change. When we do solar geoengineering, we're compensating the climate, but in a very different way. So for example, with solar geoengineering, we don't address issues of ocean acidification, which is the process by which carbon dioxide deposits in the ocean and makes the water more acidic. We don't address that, but it's not only that, the compensation is very different. So, well, the previous presenters have shown that and discussed the fact that climate change affects different regions differently. So, for example, the north of Brazil is affected differently than the south of Brazil, or Argentina different than Colombia. When we introduce solar geoengineering, those changes change. So now we're going to see differences in who gets warmer, who gets cooler, and who gets drier and who gets wetter, as the previous presentation showed in Latin America. So this sort of imperfection also matters when we think about governance. So from an economic perspective and from a governance perspective, these three characteristics are the ones that are more salient. So to repeat, it is cheap, so individual countries can do it. It can be done really fast, and it has high leverage in the sense that only a little bit of sulfur in relative terms can change the climate a lot, and it's imperfect. So those three components is what is going to determine how we try to govern this technological solution. So those three characteristics pose several challenges that I just present here in terms of questions. The first question is, how much are we supposed to be doing? Who is going to decide how we do it? When? That means when do we start doing it? And when do we decide that maybe we should stop doing it? And how are we going to deploy it? So again, in the previous talk, we saw that you can implement geoengineering by injecting it at different latitudes. And that implementation at different latitudes have different implications in terms of who benefits. So there is some amount of controllability on how we deploy geoengineering. And all of this obviously create big problems for the way we understand the governance of the technology. So let me start with how much. So this comes from a recent publication that I had with my student Tony Harding and my longtime collaborator Kate Rickey and others, in which we analyzed the use of geoengineering to stabilize climate. But not only that, we asked what happens if we overcool. And this highlights the question of preferences, in the sense that countries are going to want to implement different amount of geoengineering. In a warming climate, some countries are going to suffer more than others. So that means that some countries want to do more geoengineering than others. But every decision to do geoengineering is not benefiting everybody equally. There are going to be relative losers and relative winners. And those differences are complicated. So for example, here in panel A, we see the impacts on economic growth caused by climate change if we assume a high emission scenario, RCP 8.5. And what we see is most of Latin America here is suffering in terms of economic growth. So they will see a reduction in the rate of growth. And these are countries, again, as our first speaker was saying, those are countries that actually are in the process of developing. So they will be doubly hit because they are already poor or in the process, and that process will be stopped by climate change. In this panel C, we said, okay, what if we just mirror the warming? And instead of having 8.5, we have something equivalent to, in terms of temperature, to the negative of that in terms of geoengineering. And what we see is that most countries fare very well, yeah, in terms of economic growth. And this is important. We are not talking about climate and different climate indicators. This is just looking at economic growth and at the country level. So there are still within country issues that we cannot address with our study. But at the country level, and just focusing on economic growth, it seems that climate geoengineering does the job that is promised to do. Everybody kind of goes back to the case in which they were not geoengineering. But what is interesting in our case is that there are countries, let's say Colombia, that is getting too hot, so they would like to do a little bit more. And if they do their preferred amount, then countries that used to gain or not suffer as much from climate change start to suffer. So if you compare this panel A with panel B, it kind of flips. And now that says, like, if you do too much engineering, now countries in Europe are going to start to suffer. Countries like Canada are going to start to suffer in terms of economic growth. Yeah. So it's this difference that create a challenge. Like, how much are we going to implement? And this is where the international governing institutions matter. The next question is who is going to implement this? And this should come as not surprise that probably the countries that are either richer or with more military power are going to be the ones that determine who implements this. If we leave everything untouched and we just allow things to evolve, then countries with more power are the ones that are going to be deciding this. This is what the figure shows in another paper that I published back in 2013, again with Kate. And what we see here is that this bottom point for each one of these different regions, South Asia, Mediterranean, this bottom point determines what is their preferred amount of geoengineering, because that reduces damages, the impacts of climate change. And if you look at this, everything is very close to 0.2 aerosols optical depth. So 0.2 is just a fifth of what we need to compensate for 2.5 watts per meter squared. Yeah, so let's assume we get to something like 500 ppm and we compensate with this. But if you take those preferences and we weight it either by population or by GDP, we see that those preferences actually diverge substantially. And that means that actually countries that have either higher population or higher GDP are going to be the ones determining the amount of solar geoengineering that they want to be implementing. So if, for example, if it's driven by population, we get something closer to 18.5, but if we get something like GDP, I would prefer a amount of solar geoengineering can be 0.22. So this variation in preferences that I just showed you in the map above gets larger and is exacerbated by the fact that actually there are already built-in differences in power and capacity to implement. Yeah. The third challenge shows when I divided in two, and I think about this in two ways. First is, when do we decide collectively that it is beneficial, assuming that we figure out how to manage all this imbalance of power and we know how much to implement, which is already big ifs. suppose we have that figured out. The question is, when do we do it? And that requires a threshold or an agreement. And then the question is, so if, let's say, is when we reach 1.5 degrees, 1.5 degrees in which part of the planet? Are we going to prefer or give preference to small island states, or are we going to give preferences to other countries? So that question of when to start is hard, which follows from the question of when to end. We know, and this is what this paper chose by Kena and Damon Matthews, Ken Calder and Damon Matthews, is that what we want to do is not to just end it abruptly. Because if we have been doing geoengineering and we haven't done much in terms of mitigation, so that means the climate would have warmed in the absence of geoengineering. If we just stop from one moment to another, then we see this spike on temperature where the climate actually tries to catch up to the warming climate in the absence of geoengineering. And all climate impacts, all damages, are mostly a function of the speed, of the rate of change. So this will create a lot of impact. So now, if our goal is to deploy a geoengineering program that we use to chafe the peak on the warming curve, so that means that the intention of our program is to eventually stop using geoengineering, then we should decide when to end before we start doing it. The conditions. And the final question is how to deploy it. So again, the who wins and who loses, or by how much. And I'm talking about relative losses, not like absolute losses, in the sense that geoengineering, according to simulations, really doesn't cause damage. It just differentially compensates for them. If we deploy it in different ways, we are going to have different gains. For example, in this panel D here, the compensation happens only in the equator. So we put all the 13 megatons of SO2, we put it in the equator, and that signal, the temperature, is different than if we distribute the same amount, but in 4 different points. This is exactly what the experiment in the previous talk described as well. But that means that if we get to control the deployment and the impacts to a large extent, super broad and very coarse, well, now we have question of how do we do this? Should we compensate in a way that benefits tropical countries, or should we do it in a way that benefits northern countries, southern countries? So this starts to ask questions. So these are difficult questions. These are new questions in the sense that they only appear because solar geoengineering has these 3 characteristics of being inexpensive, immediate, and imperfect that are not addressed previously in the literature, and also they haven't been addressed in the international community because we are not used to those. We are used to a particular set of problems that come from the fact that mitigation is a public good and that people want to free ride on this public good. But this is a much different problem. So let me talk to you about some possible governance structures that have appeared in the literature, but are by no means exhaustive. And I think this is where the research is going right now. The first one is what we call exclusive coalitions. In this paper, the goal of this paper was to show what happens over time as we continue to put more sulfur dioxide in the stratosphere and we continue to warm the planet. What happens to the structure of the coalitions that are formed that support the deployment of geoengineering? And what we see in these little maps, and I'm happy to share all these papers, and I think they are posted somewhere, is that the countries that belong to a coalition change over time. And this is problematic in terms of stability. International governance structures depend heavily on stable coalitions. So we are trying to, what we show here is that we are trying to govern something for the next 50, 100 years, but the thing itself that we're trying to govern, solar geoengineering, creates enough changes to destabilize these coalitions. That is one problem that we show. Now, in terms of outcomes, as it turns out, in terms of climate outcomes, it's not a big deal, in the sense that, yes, the countries that belong to the coalition change, but the amount doesn't change as much. And this is what we show in these blue lines. Things are changing, but really the amount implemented is not that different. We also show here that the possibility, what we're going to see, and remember this is because different countries have different preferences for climate, for different climates. There is going to be a country that just wants to do an amount of geoengineering X. And that is the most powerful country. What this country is going to do is going to try to associate with as few countries as possible, but still gain enough momentum to pass a coalition. Let's call it 50% of population or 50% of GDP, or the country with more political power or more military power. And that country is going to ride the amount of geoengineering, and is going to do it at the expense of countries that want an amount of geoengineering or a climate that is a lot different than that one. For example, if Canada wants a climate that is colder, that is going to be the amount of geoengineering that we implement, even though, let's say, Brazil or Colombia would like some more geoengineering. And this is the difference between this blue line and this red line. So we have more damages in the red countries, in the non-members countries, compared to the coalition members. Independent of who is there, we still see a reduction of damages that is substantial. So the reduction for non-members goes up to 85%. For the coalition members, is 95%. But what is more interesting from my perspective, and what is the goal, is that we can create institutions that should achieve or could achieve a grand coalition. That means all countries. And when we look at the grand coalition, sits nicely in between. 90% of damages are reduced, and there are no issues of power. But getting to that grand coalition is difficult because of two important characteristics of geoengineering, solar geoengineering, is the fact that it's inexpensive and that it's immediate. That means that one particular country could, what we call now, free ride, after Weitzman's paper in 2015, free ride the amount of geoengineering. That means there is going to be a particular country that by itself could just decide what is the amount of geoengineering to implement. And it's very difficult to deal with that particular idea because most of our international institutions around climate change are designed to encourage more mitigation, to tell countries, look, we need to solve this issue together. So what are the incentives that we can create so that we all join these coalitions? This problem is flips it. This problem now saying, okay, what are the international institutions that we know that could actually stop people from, or countries in particular, from implementing an amount of geoengineering that might be too high. Yeah. So the alternative institutions there could be what we call clubs or issue linking. The idea of clubs is that we can say, okay, there is a governance structure in which we link the deployment of geoengineering to something like international trade. And we say, look, if you do more geoengineering that we are supposed to be doing, according to the Grand Coalition, then we're going to impose tariffs and we're going to hurt your economic growth through international trade, for example. If everything goes well, then everybody's happy and we implement the amount of geoengineering that is. Issue linking is similar, but it's not quite there. Issue linking is the general idea of introducing geoengineering within the international climate negotiation community. And the idea is simply to say, if you want to do geoengineering, you have to do mitigation. And the only way you have a say on the amount of solar geoengineering that we want to implement is if and only if you have shown that you have contributed to mitigation. Both these two approaches still require an external organization that enforces the impacts, that enforces the mechanism, the contract. And internationally, that is really hard to find because there is no way in which a particular country can enforce internationally in another countries, can enforce the behavior of other countries. It's just not how this works. So we're still stuck on that. And then some difficult problems call for crazy ideas, and then we start to think like, what if we start to consider the possibility of something like nuclear deterrence? The idea that if you implement too much of a geoengineering solution, what we're going to do is to implement counter geoengineering. So if you do geoengineering, we're going to do the opposite. And I hope you understand, this is the stupidest idea we can have, but it has proven valuable in the nuclear proliferation case. Yeah, valuable in the terms that there is wasteful investment, of course. During the Cold War, we saw countries investing in nuclear arsenal that make our lives very, very dangerous and complicated. But we never went or we haven't gone into a nuclear war. So this came from that. This is a paper with Daniel Hayen, and it is simultaneously, although almost a follow-up with a paper that Andy Parker wrote with David Keith on counter geoengineering. But what we show in our paper is that actually this idea also backfires, because we might end up in a situation in which we end up doing geoengineering and counter geoengineering, and then we end up with something that looks as bad as a nuclear winter. And it doesn't solve necessarily the coordination problem. So these figures actually show that the deployment treaty, just the blue stripe, actually with geoengineering is better than when we do the when we allow for the counter geoengineering option. So just to close, the geoengineering as a technology and from a climatic perspective, we kind of know what it does from an average perspective. We don't know much about regional impacts. We don't know much about on the ground impacts. That's what the new projects are doing on vegetation and water flows, for example, as we saw earlier. But we kind of know how geoengineering will move the climate indicators. But what we don't know is how to govern that. I think the most interesting part from my perspective, and I'm clearly biased, is that it introduces so many new questions and so many difficulties that we really need to think about this. We really need to know how this technology is different and how it complements or substitutes for current technologies or current approaches like mitigation or adaptation. And just to close, there are two points that are important to keep in mind. The first one here is that if Latin American countries and tropical countries in general and African countries don't develop their capacity to inform the conversation, they are not going to be part of the conversation. And there are important initiatives right now. Some of the one that is funding this that are this talk that are important developments, but I think it's very important to actually develop a strong voice in Latin America and the Caribbean and Central America for this. for this type of research. And the other important aspect that is also related is that climate by itself is going to affect poor people more than rich people. We know this, and the environmental justice problems associated with climate change are not going to be solved with geoengineering. If anything, they could be exacerbated because we won't have equal access to the decision to manipulate the stratosphere or the environment. And I think a conscious effort to actually make institutions that allow for that conversation to happen broadly, to have different voices, is really important at this time. And any governance structure needs to come out from that process. It cannot come out from few voices in the US or Germany. It has to be broad. So that's my hope, and I hope this program continues that process. Thank you very much.
Juan, muchísimas gracias. Estamos pasados de tiempo unos 10 minutos, pero creo que todos estaremos de acuerdo.
Thank you very much. We have exceeded our time, but these are very interesting presentations. So if it's okay with you, let us discuss 5 more minutes. I ask the panelists, please open your cameras, your videos, so that we can have a conversation. I would like to thank you, all of you that raised questions. I will summarize them. Inés and Pablo, please turn on your videos, cameras. There are some things that are worth the while to bear here in mind, and I would like to raise them to you, to the 3 of them. A group of questions is about risks / opportunities through the modification or solar radiation management. And another group of questions is, what is the role that South America or Latin America and the Caribbean can play in this scenario? I would like to ask each one of you, Paulo, Inés, and Juan, to give us one word. What's the main risk you see, and what's the main opportunity you see insofar as solar radiation? Paulo, please, you start. The main point is reduction of greenhouse gas emissions. As a presentation of Inés and Juan clearly expressed, the dangers linked to geoengineering that is not appropriately implemented are enormous. So the best strategy in geoengineering continues to be reduction of the greenhouse gas emissions as fast as possible and as strongly as possible. Preferably in 2050, we would have to have 0 emissions of greenhouse gases. And the great problem, the agricultural sector producing food emitting 25 to 30% of emissions, mainly methane. And this is very difficult to mitigate. Therefore, our societies have an enormous challenge ahead, and that is an urgent challenge. And that was clearly stated in Inés's presentation. Very well. Thank you, Inés. What do you say? Well, I would add to what Paulo said is that another word that can characterize geoengineering that is uncertainty in the present status. There are many things that we don't understand about geoengineering. Simulations conducted are linked to sulfur dioxide because we had volcano eruptions and we know how the atmosphere responds to the sulfur dioxide. Geoengineering, what is raising if this is implemented, it's not to use sulfur dioxide. We know it does have an absolutely negative effect, for example, in destruction of stratospheric zones, but rather explore the use of other substances. But still, we need a long way to tread in knowledge. Of course, to have parallel progress, scientific research, possible impacts, and at the same time, discussion of governance. It's clear that it's not going to be developing countries of Latin America, the ones that will implement these technologies. This will come up from other countries. However, we need to participate in the discussion, mainly because of what I said before, consequences of climate change and the implementation of these technologies are asymmetric. So we need to have a voice as a region participating in governance and being aware of the possible consequences of these new technologies. And this has to be science-based and with a regional contribution to scientific knowledge is key in this question.
Thank you very much. Juan? What Pablo and Inés said we should not think of geoengineering independent from the rest of the things we do. The real risk is the emissions. And if we don't want that risk, well, we do not have gas emissions. But still, there are consequences of global warming and the atmosphere that we need to deal with. For me, one of the problems is that from the point of governance, is that discussion should not be so separated from science, because we might run the risk of not implementing it. I hope that doesn't sound like someone who is 100% in favor of geoengineering, because that is not the case. But I believe that the risk of not implementing it because of fear or non-scientific reasons is as large as the risk of implementing it. So a science-based conversation is very important. Understanding policies of the countries will implement it, but basically scientific discussion. And here I endorse what Inés said, that voices of Latin America are important not only from the standpoint that everyone wants to participate, but our problems as Latin Americans are different. And our voice is important not only to complement on the idea of having a global position, but it is because our problems are different and our ideas are different. And ask for a seat in the negotiations from the very start is fundamental. That leads me to other questions. One, I will start with you. What do you refer to, and Pablo also touched this, as the Latin American perspective should require for a space in the negotiations? What would you be expecting from that type of participation? I'll start with you, Juan, and then Inés and Pablo. There's two problems, in my opinion. The first is that research starts from the perspective of developed countries, and the type of questions they ask about the implementation of geoengineering are very different from the points that matter to us, Latin Americans. This moment, I'm on the two seats as working in Canada and as a Colombian. I know that the questions that interest us as Latin Americans are not the questions that we are asking from the international perspective. For example, I'm very interested as a Colombian to know what's the impact on coffee growing. But if you see the international publications, that is not a question that appears. There's many reasons why it doesn't appear. I particularly believe because of a lack of interest. But there's another important one, which is technological. We don't have the necessary models yet to understand how solar engineering might affect those details, such as how much rainfall there is in Medellin, etc. So there are technical considerations. If we, Latin Americans, participate, those questions appear. The question Sines is asking in the South American countries, and she said it, those rivers affect navigation, which affect the way in which agricultural products are distributed. These are local questions that we need to participate for them to be part of the international conversation. At the same time, when the questions appear, we need to demand that the techniques, that the models be capable of approaching these. The first step we now see, which is decimals, takes the global international models and says what type of questions you want to ask. But at that moment, we're still using models which are not designed for us and questions which do not consider the Latin American perspective. And that's what I would like to see. I would like to see participation on the type of questions asked and how they are responded. Now, how do we get to the negotiations table? That's normal now. There's panels in the United Nations. The conversations will take place, and Latin American countries have weight in those negotiations. So, apart from the international questions, let us ask the issues that interest us, and not only those questions that interest the developed countries. Thank you, Ines. I would add funding issues. One of the issues relates to who funds research in these issues in the Latin American region. The resources available for research in all our countries are usually quite limited. We are investing resources to research what are the consequences of climate change, phenomena of which Latin America are not truly very responsible, at least in terms of historical responsibilities of climate change. We must also add resources to research what could the consequences be if we implement geoengineering. So I believe that international cooperation is needed to advance in knowledge and strengthen research in countries who probably have lower contribution as causal agents of the problem, but who do suffer the impacts as well. You need to form part of the global discussions of implementation or the possible implementation of these technologies. I would like to remind that the climate models currently used by IPCC, for example, are 28 climate models that are different. And they have one very strong deficiency, which is the prevention of precipitation. The hydrological process is not very good used, not very well represented here in the climate models. And alterations of the hydrologic cycle are one of the potential alterations that are quite significant for Latin America and the Caribbean. And the models cannot still supply the answers with the accuracy that we need. So that is very important. The second aspect played by Andes, which is the issue of financial resources. Latin America needs to invest strongly in research on climate adaptation. So limited resources in Brazil, Argentina, Peru, Bolivia, the issue of adaptation of climate change becomes very urgent. So apart from moving ahead and increase our research policy and potential techniques of climate engineering, even though positive is very good, the initiative mentioned about decimal is extremely positive. And we need to have a process such as decimals, but ongoing, but funded by the Latin American countries in order to be prepared for a future which is getting here, and it is not at our doors. But it is important to know that the issue of climate adaptation is critical. For example, there were tremendous changes in the water storage systems throughout all the Andes, going from Argentina to Colombia. So temperature rise will alter the hydrologic cycles in most of Latin America. And what are the impacts? And how can we adapt ourselves to these changes? These are critical issues. The Inter-American Institute for Global Climate Research, where we participate, is working at that. But we need to advance much in the issue of climate adaptation, apart from researching about these technologies on climate intervention that most certainly will be with us in the coming decades. Pablo, you were saying that one of the main risks are related to hydrologic cycles, but there is a question that I believe is very interesting as well, and it is how can geoengineering modify solar radiation in the region? Yes, I saw that question. You know, all the geoengineering technologies that Ines mentioned, a few, aim to restore the balance of reactive atmospheric balance. We're talking about 2.4 watts per square meter. And those 2.4 watts per square meter are very low compared to the total radiation in the surface. So none of those geoengineering techniques will directly affect the use of solar energy in Latin America. The main impact with the increase of diffuse radiation as compared to red radiation essentially also is relatively small. So the greatest alterations will not affect the harnessing of solar energy in Latin America. Thank you. Ines.
I wouldn't add anything else to that answer. Perfect. Then there is one additional topic, and that is what really concerns us in this webinar, and this is more moving to a close. I would like, Ines, I would like to have the last question for you, Ines. If you had to adopt one first decision in geoengineering in governance terms, what is the first step you would take?
Inés,
Sí.
¿posso começar? Vai, Inés.
Inés.
Bueno, con respecto a la gobernanza.
Regarding governance, I think the first thing we can do, I come from the area of science, and I think that the role we need to play is to inform the decision makers and those that represent us as countries in multilateral agencies, UN, those representatives. It is in those areas where issues related to governance will be discussed and geoengineering. So the role of science is one of providing all the information for our representatives then to adopt informed decisions on how to act without losing sight of the fact that climate change is a global problem. Solutions need to be global, so any governance entity needs to be globally represented. That is why I mentioned the UN. That would be sort of the natural umbrella where this should be discussed. I think that the first step on climate geoengineering is to study it. Science is very far from having responses. For example, is it feasible to inject aerosols in the stratosphere at large quantities continuously on several decades? We don't have scientific answers for these questions. And also we have the issues mentioned by Eduardo on the governance. We need that our countries, Latin America and the Caribbean, to work more jointly together, seeking solutions that be adopted as a block on global climate issues. So governance not only of geoengineering, I say governance of mitigation of emissions of climate change. The Paris Accord or Paris Agreement is very shy, very timid. Brazil is not going to meet its target. Therefore, there is deforestation in Amazonia with tremendous emissions, and there are no governance mechanisms that can prevent a country from practicing, for example, such deleterious actions in our planet, and unless they are all together. So we need to structure a cooperation network on governance related to climate and related to climate geoengineering. That is extremely important for Latin American and Caribbean countries. Thank you, Juan. The only thing I would add is that the first step for me would be to develop policies ensuring that research be done in a way integrating all voices, all countries, and not to leave research as something like common, like we are researching electric cars. No, this has global impact, and therefore it needs to be legitimate. And any form of governance needs to seek that geoengineering research be legitimate. And that has different issues. Financing. It needs to be from all countries. Or say, we don't want private agents in financing. The results and experiments need to be communicated in a central report. There are things that you can do before beginning to research. But the idea is to legitimize the research. Is very important because, as I was saying, this research will shape the policies. And if the research is not legitimate, then the policies that will stem from that will neither be legitimate. So that's my first step, to look for ways of participation of everyone in the research in a cooperative manner. Very interesting. So I would like to thank everyone. Let's Lack, for for all your support. I mean, we have already exceeded time. I would like to thank C2G, CEPAL, Euroclimate, Euroclima, and on behalf of Let's Lag, I would like to thank Paulo, Inés, and Juan. It has been a true pride to share, an honor really, to share with you. And we're very proud, really. Thank you very much, and hope to see you in a future opportunity. Thank you very much, everyone, for the opportunity.